Okay, so we have this interesting question here, and it says a car starting from rest increases its speed at constant rate. Calculate the distance it travels in 4 seconds if it travels 144 meters in 8 seconds. And we have some options here. But here they said a car starting from rest. So if it starts from rest, it means that solution, it means that our initial velocity will be 0. Then it increases its speed at constant rate. That means the acceleration is constant, has the same magnitude. They now said calculate the distance it travels in 4 seconds if it travels 144 meters in 8 seconds. Oh, we have that it travels 144 meters in 8 seconds first, and they're asking us to calculate the distance it will travel in 4 seconds. Okay, that means since it travels 144 meters in 8 seconds, my t1, because I have two values for my time here, t1 will now be my 8 seconds, and my t2 will now be the 4 seconds. And then 144 meters is my d1, first distance. They're asking us to calculate the second distance in 4 seconds. So, and you know, of course, when we're dealing with linear equations of motion, we're going to use s to represent our distance. So s1, now we're going to use s1 will be 144 meters, and then s2 is what they want us to find, question mark. So definitely we'll have to check which of the equations of linear motion will suit this question. So I've written them out here. So we have v equals u plus at, we have s equals ut plus half at squared, we have v squared equals u squared plus 2as, and then we have s equals v plus u over 2 all times t, although the last one doesn't contain acceleration, so we'll just focus on the first three. So now we have UTS. So which of them has UTS? So, and which of them has UTS and acceleration, since they said the acceleration is constant, and that will be the second equation. It has UT and S, and of course it also has acceleration since they said it's constant. So this equation is our best bet. So we're going to use this one to solve. But while using this one, we have to be careful, because in this case, since they give us T1 and T2, and they give us S1, and they say we should find S2, don't forget they said it travels 144 meters in 8 seconds. Then how long, or what will be the distance it will cover in 4 seconds? So that's why your T1 is the 8 seconds, and your T2 is now the 4 seconds. And then your first distance, your D1 or your S1 is 144 meters. They say we should calculate the second distance, that's the one it will cover in 4 seconds. So we have to check the relationship between T and S, the kind of proportion we have between T and S. Is it going to be direct, or is it going to be inverse proportion? So let's write out this equation that suits this problem out. Let's write it out. So we now have, since we have chosen, we're writing S equals UT plus half AT squared, and we know that our U is 0, so I'm fixing 0 for U. So we now have S equals 0 times T plus half AT squared. So we now have S equals 0 times T is 0, so that one has gone, so we're left with plus half AT squared, so plus half AT squared. So this is what we actually need to now see how to get the proportion, the type of proportion between S and T squared. And of course, following horizontal tests, from this equation we are looking at, we now know that S and T squared are directly proportional. So that means if you increase S, also then the T will also what? Increased. So we now know that S, if you increase S, then T squared increases also. S is proportional to t squared. So we are looking at only the s and the t according to what we have as parameters in this question. So if s is directly proportional to t squared from this equation of linear motion, remember I made my u 0, and 0 times t gives you 0, and that's going, 0 is nothing. So that's why we have this one. Then converting this to an equation, we now have s equals kt. You are going to introduce a constant k to make it look like an equation, or to make it become an equation. So introducing the constant k, then you still have your t squared. It is now an equation, but we still have to find the value of the constant k by dividing both sides by t squared. We want to make k the subject of the formula. So dividing both sides by t squared, so t squared cancels t squared here. So we will then have that k equals s over t squared. So k equals s over t squared. Then from this, since the constant value is s over t squared, we can now duplicate the s over t squared. We'll now have s1 over t squared 1 equals s2 over t squared 2. And mind you, this is what we're looking for, s2 question mark. So every other thing is complete. We just fix them here, and then we cross multiply, and we are good to go. So what's my s1? S1 is 144. So I have 144 over my t1. Remember, this is t1 squared. T1 is 8, then equals to, then my s2 is what I'm looking for. I'll leave it that way, over my t2 squared. Oh, I'm going to square this one. Remember, there's a square here, so I'm going to square the 8. Then my t2 is 4, and of course it said t2 squared. I'll square the 4, and then I can now cross multiply. But before I do that, I have 8 squared, which is 64. So I have 144 over 64 equals s2 over 16. So that's it. Then we can now cross multiply. So 64 times s2 gives us 64s2. 64s2 is s equals 144 times 16. 144 times 16. You can leave it that way. Then we now divide both sides by 64. So dividing both sides by 64. 64 cancels 64. I'm left with my s2 equals 16 in 64 is 4. Then I'm left with 144 over 4. 144 over 4. Then 4 in 1, it can't divide. Then 4 in 14 is 3. Remember, 2 in 24 is 6. So my s2 is definitely 36 meters, which is my option B. So that's it. Very simple.